friends, and welcome to Classroom Teaching. I am Shekhar, your science teacher. Students, today we are going to perform a very interesting and very simple activity, and I will ask few questions which are very simple questions, and take a notebook and pen and write the answer of that question in your notebook, and then check whether it is correct or not. It is interesting to do. So take a pen and register. Notebook. Look, friends, I have a ball in my hand. Just tell me whether any force is acting on this ball or not. Yes or no? Yes or no, you have to write that in your notebook. Okay, so the actual answer I will tell. Definitely the force is acting on it, because we know gravitational force acts on every object. So it definitely acts on this ball also. Then tell me why this ball is not falling down. That means why it doesn't get attracted towards the earth. Why? The answer is very simple. That because I hold this ball in my hand. So whenever I hold this ball in my hand, which other forces are acting on it? The ball, as it is not going downward. Why it is not going downward? Because I apply force on this ball which is same in magnitude but opposite in direction to the gravitational force, and therefore the ball doesn't go down. It remains here because I apply force on it. If I release this ball, then what would happen? Observe it. So what is your observation? The ball, it falls down. But while falling down, which are the forces acting on that ball? Now write the answer. Whenever I release the ball definitely falls down. That is our observation. Then which are the forces acting on that ball now while falling down? Definitely only one force is acting, and that is nothing but gravitational force. Friends, whenever the object is falling down, in the influence of gravitational force alone, it is said to be in a free fall. So today we are going to discuss about what is free fall. The definition, now it is very clear to us. What is free fall? If any object is moving under the influence of gravitational force alone, then it is said to be in free fall. Two words are very important in this definition: alone, and second, moving. I am not saying it is falling. It is moving. In this activity, we have seen the ball is falling down. But if we think about the satellite, whether it is artificial satellite or any other satellite, natural satellite like moon. Moon also moves, or artificial satellite, it moves around the earth. It revolves around the earth under the influence of gravitational force alone. Moving under the influence of gravitational force alone, then it is said to be in a free fall. And therefore the gravitational, if there is no other forces acting on it, you must remember the activity that we performed in last video. Two objects of different shapes and different masses, if we release them from same height, then they fall on the ground at the same time, because they are freely falling objects and they are under the influence of gravitational force alone. And one more thing, the value of g, that means gravitational acceleration, it depends on mass of earth only and not mass of object. Students, the gravitational force, whenever we are talking about free fall, we must remember the object should be released only. That means the initial velocity u must be equal to 0. And the second thing that we have to remember, that is nothing but the acceleration, it is nothing but acceleration due to gravity. So A, that is nothing but we use for acceleration, it is nothing but gravitational acceleration, that is nothing but g. So by using these two changes, we can rewrite all the formulas which the Newton's formulae of motion, Newton's laws of motion that we know. So Newton's equations of motion we can convert it for free falling object by just using these two changes. So what are the Newton's three equations of motion? I will write it here. First equation, V is equal to U plus AT. This is our first equation, Newton's first equation of motion. What is second equation? S is equal to UT plus half AT square. And the third equation is V square is equal to U square plus 2AS. So we convert these three equations of motion for freely falling object. These two changes we have to make here. These two changes. So these changes to V is equal to U is 0. So instead of A we write G here. So V is equal to GT. Second equation, S is equal to, S is displacement, S is equal to UT, U is 0, so this term becomes 0, half GT square. S is equal to 1 upon 2 GT square. And the third equation is V square is equal to 0 plus 2GS, that is nothing but 2GS. So these are the three equations of motion, Newton's three equations of motion for freely falling object. And from these equations of motion we can find out the final velocity of the object and the time which is required to reach the object to the earth for a freely falling object. So what is free fall? Free fall, it is nothing but if the object is moving under the influence of gravitational force alone, then it is said to be in a free fall. We are saying moving because we have seen the example of satellite. Satellite revolves around the earth, but it is also in a free fall state because they are revolving under the influence of only gravitational force. So these two words, alone, gravitational force alone, and moving. So this is nothing but free fall. Students, in yesterday's experiment, in the experiment that we performed in last video, if we repeat the same experiment here also, because look, I took a ball and a paper. According to the concept of free fall, or as we know, the value of gravitational acceleration is independent of mass of object or property of any object. These two objects, if I release them from the same height, they must fall at a time. That means they must reach the earth surface at a time. So let us try it. You can try it at your home also. So if I perform this activity, then here we can see the ball, it reaches the earth first, and then the paper, it floats in the air, and then it reaches to the earth. So why it happened? Because whenever the object is falling under the influence of gravitational force only, then gravitational acceleration for all objects, it is same, for same heights, and therefore they must fall at a time. Why it doesn't really work here? The main reason for that is two forces, they are acting on it rather than gravitational force. Which are these two forces? The first is frictional force and the second force is buoyant force. So frictional force, that is nothing but friction of air, the resistance of air, and this depends on the volume of the object and the mass also. The mass of ball is very much heavier than that paper, and therefore ball doesn't or the air cannot resist it more, and therefore it falls down fast. And the second force is buoyant force. We all know, we learned it in 9th standard. Any medium, fluent medium, any fluid, whether it is liquid or gas, whenever the object go through it, it pulls that object or it pushes that object in upward direction. Upthrust force is there. So that is nothing but buoyant force. And due to these two forces, ball, it falls down first and the paper after that. Actually, the similar activity that we performed in last video, it is performed by Galileo also in Italian city, that is in Pisa. We all know the Leaning Tower of Pisa. So Galileo dropped two spheres of different shape and different size and different mass at a time, and he showed that both they reached the ground at the same time. And this activity was performed in 1590. But after few years ago, that means after before 2-3 years, in 2018 or 19, scientists performed the similar experiment by using feather. A very lightweight feather and a heavy ball of metal. They create a vacuum in very large hall, and in that vacuum they tie a feather and a heavy ball and they release them at a time and observe whether they fall at a time. So what was the result of that experiment? We can easily see. This video is available everywhere, so we can see this video here also. Both the feather and the ball, they fall on the ground at a time because the vacuum is created. So from all this discussion, we conclude that free fall, true free fall, it is possible only in vacuum. Whenever no frictional force is there or no buoyant force is there, because as there is no air, no medium, buoyancy is not there. That means buoyant force is also not there. So finally, what is free fall? Whenever the object is moving under the influence of gravitational force alone, it is said to be in free fall, and true free fall is possible only in vacuum. Friends, the second concept that we are going to discuss today, it is gravitational potential energy. It is also a very simple concept, very small concept that we are going to discuss. Gravitational potential energy. So let us recall first what is potential energy or what is energy. We learned in 9th standard what is energy. We learned the concept from the work. What is work? If we apply force on any object and if the object gets displaced, then the work is said to be done in physics. In lockdown, we are performing a lot of work that we think at home. But in physics, the work is nothing but if displacement is there by the application of force, then only work is said to be done. That is nothing but W is equal to F into S. If S is 0, no work is said to be done. And what is energy then? Energy, it is nothing but what is energy? Energy, it is nothing but equal to work, because it is the stored ability to do work. The energy itself converts into work, and therefore it is calculated by F into S. What is potential energy? We know the two types of energy, potential energy and kinetic energy. Kinetic energy, we all know that is nothing but by virtue of motion. And what is potential energy? Potential energy is the energy possessed by an object by virtue of its position and configuration. And this potential energy is given by the formula potential energy is equal to mgh. We derived this formula in 9th standard by this formula. F, it is nothing but, we know F is equal to mass into acceleration. But as we are talking about gravitational acceleration only, because the object is under the influence of gravitational force only, therefore we write it as m into g. And as the object is falling down, how much displacement is taking place? The displacement, it is nothing but measured in height, and therefore we write this S as h here. So it is the formula for potential energy. And we call this energy, potential energy, as gravitational potential energy. Why? Because we are talking about gravitational force and we are talking about the displacement taken in vertically downward direction due to that gravitational force. And therefore, gravitational potential energy, it is nothing but given by mgh. We learned for the smaller heights. Suppose this is Earth. We know if the object, it is at a height h, from the surface of Earth, the potential energy is mgh, where h is the height from the surface. And we assume that the potential energy of any object at the surface, it is potential energy, we assume it to be 0 on the surface of Earth, because we consider the height h is 0 and therefore we consider potential energy is 0 in that case. But it is true for smaller heights. We say as we go above the surface of Earth, that means we are increasing height. Definitely from this formula, potential energy also increases, because for smaller heights, g is constant. That we learned. In last video, we have seen the example of aeroplane. If the aeroplane is at a height of 10 kilometers from the surface of Earth, that 10 kilometers, it is very much small in comparison with the radius of the Earth, which is 6400 kilometer. So in comparison with the radius of the Earth, this 10 kilometer, it is very small distance, and for such small distances, the value of g is constant, and therefore we can say potential energy, it increases whenever the height increases. So this relation, we can say this is true for smaller heights only. Why I am saying that for smaller heights only? Because we know as we go above the surface of Earth for larger heights, that we see, we have seen one example of, suppose, communicable satellites. They are at a distance of 35,700 kilometers from the surface of Earth. And 35,700 kilometers, it is a very large distance in comparison with 6,400 kilometers. That means radius of Earth. Suppose the object is here at very large distance. We know as we go above the surface of Earth to very higher heights, then the value of G goes on decreasing. At the communicable satellite, at that place, the value of G, it is around 0.25 something. So this much small. So as we go above the surface, if we go still more at some more large distance from that, suppose here the object is, if we go large distance, then the value of G goes on decreasing continuously. And at infinite distance, suppose here it is the distance, it is infinite distance. At this infinite distance, the value of G, it becomes 0 here. And if the value of G becomes 0, potential energy definitely becomes 0. Because anything into 0 is 0. So potential energy becomes 0 at infinite distance. It is the distance where the gravitational force doesn't act. Because Earth's gravitational field, it is up to here only. After that, the gravitational force doesn't work. Therefore, there is no gravitational force, so there is no gravitational acceleration. And if gravitational acceleration is not there, then value of G, it becomes 0 there. And if the value of G is 0, potential energy is 0. So, instead of here, if the object is here, tell me, here we say potential energy is 0 here at infinite distance, and it is convenient to say it is the properly we can say potential energy is 0 at infinite distance. If we take a distance somewhat lesser than that, suppose we take object here, then what should be the value of potential energy is here? Potential energy. What should be the value of potential energy? It must be less than here. Because we know as the height increases, potential energy increases. So, if height decreases, potential energy also decreases. So, here the height is less and therefore the potential energy is less than. Potential energy is less than, which is here. And here the potential energy is 0. And therefore, we can say the potential energy is negative here. Again, if we come here, then it must be less than that. If we come here, it must be less than that. So, instead of taking the potential energy as 0 on the surface of Earth, actually the potential energy is 0 at infinite distance. And for any distance less than that infinity, the potential energy must be negative. And it is given by a formula. This formula is directly given. Potential energy is equal to minus Gmm upon R. R, or instead of R plus H. This is the value of potential energy, and this formula is directly given. The formula solution of this formula, or from which the derivation of this formula, is not given in 10th standard. It is in 11th standard. So you can easily derive it. Use your brain power. From this formula, if we replace the value of G by that we see in last period. So we can easily derive this formula also. You have to rectify. If you cannot derive it, just rectify it, because the derivation is not given in standard. So potential energy is equal to minus gmm upon r plus h. In this formula, we know G, the value, it is universal constant, it is 6.67 into 10 raised to minus 11. M, it is mass, it never be negative. This is M, it is the mass of object, it is also never negative. R and H, these are distances, and the distances are also positive always. That means they also never be negative. But this negative sign here, it is due to, or the explanation for this negative sign is given here. Any distance less than infinity, because we know the potential energy is 0 at infinite distance, and any distance which is less than infinity, it must be negative. Like here minus 3, minus 2, minus 1, 0, like this. The potential energy goes on increasing and it becomes 0 at infinite distance. So this is about gravitational potential energy. The potential energy we calculate for gravitational force only, and therefore it is gravitational potential energy by virtue of its position that we are taking height from the surface of Earth. So in this, just remember two things. For smaller heights, we consider the G is constant, and as H increases, the value of potential energy also increases, and it is considered to be 0 at the surface of Earth, that we assume. But actually what happens for the higher distances, the value of H increases, but at the same time the value of G, it goes on decreasing and it becomes 0 at infinite distance. And therefore at infinite distance the potential energy becomes 0 there. For any distance less than that, the potential energy must be negative. The reason can be asked into the exam. So students, here we stop. So these two articles that we have seen, free fall and gravitational potential energy. So in next video, we will complete this chapter. The last article is there only, and that is nothing but escape velocity. Okay, thank you.